Hello everyone, and welcome back to another Eng 130 video tutorial. In this tutorial, we're going to learn how to solve for an unknown coordinate point if we're given the force vector. So it's very similar to our previous examples. Instead of working from the position vector to the force vector, we're actually going to work backwards and try and find an unknown coordinate point. And these questions are great because they'll likely show up on a lab because they really test your knowledge if you know what you're doing with the formulas. So with that being said, let's begin. Alrighty, so looking at the question, it says if F is equal to, and then a big long force vector, and cable AB is 9 meters long, determine the X, Y, and Z component of point A. So point A is the one up here, and that makes sense because judging by our axis, we know that coordinate points down here at B are going to be 0, 0, 0, since it's right at the origin. So the best thing I like to do to start these kind of questions is let's just write down all the information we're given, because then we can start to decide, okay, what's missing? What do I need to do? So looking at this, we already said that B is at the origin. So B, the coordinate points of B are going to be 0, 0, 0. And since we're not it says cable AB is 9 meters long. So our units for this question are going to be in meters. All right, so what else do we know? Well, it says the length of cable AB is 9 meters. So as I was saying in the previous example, when it says that the length of something is 9 meters, that means the magnitude of the position vector AB. So the magnitude of position vector AB is equal to 9 meters, and that's going to be important later. And then finally down below, I'll have to write it down here just because I won't have enough room. We know that FAB, the actual vector itself, is equal to, and let's put in brackets, 350i, so 350 newtons in the x direction, minus 250j, minus 250 in the y direction, and then minus 450k. So that right there is going to be in the the z direction. And again, it's a force vector, so it's going to have units. And in this case, if we look up to the top, the units are going to be newtons. All right, so this is all we're really given in the question here. But based on what we have, we can start solving for some quick unknowns. The first is if we have a vector, and this could be position or a force vector, and we have all of its components, we can solve for its magnitude. So if we have the force vector AB here, what we can do is we can solve for the magnitude of FAB, so that basically the length of FAB, not the length in a distance sort of sense, but the magnitude of the force, how strong that force is. So it's going to be 350 squared plus 250 squared plus 450 squared. Ta-da! I'm just going to do the top real quick. Perfect. And when we type that all in, we get 387,000. So it's going to be a really big number. Oh, sorry, it's not going to be. I'm an idiot and forgot to square that. So that's if you add them all together. But what you'll get here is it'll be equal to 622.5 newtons. So 622.5 newtons. So that's really nice because now we have another unknown. So if you think back to what we did in the last example, we dealt with three vectors usually. The first is the force vector, which has a magnitude, which we have both now. The second is we have a position vector, which also we have to deal with the magnitude, but we have the magnitude, but we don't yet have the position vector itself. And the third one, which is kind of what we use to switch between the two, is the unit vector. And again, we don't have the unit vector. But remember that a unit vector can be found if we both know the magnitude and the vector itself of a force or a position vector. And right here, we already know FAB as well as the magnitude of FAB. So we can find the unit vector AB, because that's going to be equal to FAB, so the vector itself, and then divided by the magnitude of FAB. Like so. So I can just put my divide sign there. Good enough. So what we're going to end up with for the unit vector, it's going to be equal to, and it's a vector, so we're going to use the squiggle brackets. It's going to be 350i, oops, 350I, and that right there is going to be divided by the 622.5. And then we also have to go minus 250J. And this is going to also be divided by the 622.5. And then minus 450, and that's in the K direction. And again, we have to divide it by 622.5. And this is a unit vector, so it has no units. And again, if you're wondering why, we have 350 newtons up top here. We divide by 322 newtons, so the newtons cancel. So that's why it has no units. Alrighty, so next we can start using the unit vector to transition from our force vector to our position vector. Because this formula up top here, which I'm going to star, we can also use that for position vectors. So what we can do is we can find the position vector RAB, because that's going to be equal to the magnitude of RAB, which we already know. We know it's 9 meters, times the unit vector UAB. So we put all that in. We know that the magnitude is 9 meters, so I'm going to put 9 here. And then the vector itself, I'm going to actually just put its decimal form, because I like to kind of see the magnitude of each component. So 0.562, 0.562I. So again, this number just comes from dividing 350 into 622, and minus 0.402 minus 0.402, and that's in the J direction. And then minus 0.723, minus 0.723, and that's in the K direction. So again, this one does not have units because this is a unit vector. And then all we're going to do is multiply the 9 into each one of those terms. So what we're going to end up with is RAB. So what we end up with is RAB is equal to 5.06I minus 3.62J, and then of course minus 6.51, and that's K. So now this is a position vector, so it has units, and since we multiplied 9 meters, the units of this position vector are going to be also in meters. So this is really nice, because now we have both the force vector and its magnitude, we have the position vector and its magnitude, and we have the unit vector. So everything that we've done in the previous examples, we already solved for here. So now we're not looking for the position vector, but we're looking for a coordinate point. And then this is when we use basically the formula for a position vector. So recall that RAB, so position vector from A to B, if we wanted to find that, what we do is we take the coordinates of B minus the coordinates of A. Oops, and these shouldn't have hats. So if we go into here, we already said that B is going to be 0, 0, 0. We're going to subtract the coordinates of A, so now we have to look what A is. And we're going to put this right here. So if we look at A, what we're going to do is we're going to keep it parametric. So instead of putting in actual numbers, we're just going to put in the variables. So if we look at A, we have to find out how far it goes in the x direction. So the x direction says it's going this way, but we see that A is negative x meters because it's going the opposite way. If we look at y, the y direction, so that's how far it is going this way, we see that it goes positive y meters in the y direction. And then finally, when we're looking at the z direction, so how far is A going up from the z-axis, it goes up by a factor of positive z. So A is going to be negative x, and then we got y, and then z. So in here we're going to go negative x, comma y, comma z. Alrighty. So if we were just to solve this and keeping it parametric, we're going to get that RAB is equal to, and it's going to be a vector like this. It's going to be equal to 0 minus negative x, so we're going to get x in the I direction, and then we're going to get plus and then 0 minus y. So it's actually not going to be plus, it's going to be minus. So minus y, and that's in the j direction. And then minus z, which I'll put this little thing on my z just to kind of show you guys, make it more distinct. And that's going to be in meters. So if we were to solve the position vector this way, we have 3 components. And now this is when we can start matching it up, because this is nice. Since we have these components and we already know RAB, we can just relate the components to the position vector we already found. So we must know that x right here, that has to be equal to 5.06. And if we were to look at the negative y, we know that that must be equal to negative 3.62. And finally, if we were to look at the negative z value, we know that that must be equal to 6.51. So right from this here, we can state our coordinate points. We know that x is going to be equal to 5.06 meters. We know that y is going to be equal to 3.62 meters, so 3.62 meters. And then finally, z is going to be equal to 6.51 meters. Oh, let me just erase that real quick. 6.51 meters. And then again, this is our final answer, so we're going to put a nice box over it to help show that this is our final answer. But before we end this, I'm just going to leave this a note. So this was a special case where we can say that x is equal to 5.06, y is equal to 3.62. And the only reason that that was able to happen is because of this case right here. It's the second coordinate right here were all zeros. Let's say that we had 6 here instead of 0 for x. I'm going to do this in a different color so you guys kind of follow along. So let's say instead of 0, 0, 0, let's say we had the vector 6, 0, 0. And we subtract the 2. For our component here, instead of just having x, positive x, we'd have 6 plus x instead of just x. And that right there would be equal to 5.06. So then you would have to rearrange this to solve for x. So keep in mind that this right here was a special case because the 1 point was into the origin, or not into the origin, it was the origin. However, if coordinate B was somewhere else, you would have to account for that. And so that's just my little heads up because that could definitely happen. Actually, let's be honest, it probably most likely will happen in lab examples. So I just wanted you guys to be aware. All right, so that concludes this video tutorial. I will see you guys in the next one where we start to get into some more complicated examples. And then we'll start learning a new topic, which is the angle between vectors. But I'll save that fun for when you guys are ready. All right, well, thank you guys so much, and I'll see you guys in the next video.